HelpMeWithStats.com was used to create this tutorial that can help us understand the bias in the sample sum of squares. Here we have a population of scores. The mean of the population is 5. Let's see how the sample sum of squares underestimates the population sum of squares. Let's look at a chart which contains all the possible pairs of scores that can be sampled from this population. We'll compare the population sum of squares to the sample sum of squares. We've added a column for the sample mean calculation to make things clearer. Let's start with the pair of scores 2 and 4. Let's calculate the population sum of squares for these two scores. First, let's find the squared deviation of the first score of 2. As we can see, we take the score of 2, subtract the population mean and square the result. Next, we find the squared deviation of the second score of 4. As we can see, we take the score of 4, subtract the population mean and square the result. Let's simplify the squared deviations. The squared deviation of the first score is 2 minus 5 squared, which is 9. The squared deviation of the second score is 4 minus 5 squared, which is 1. We add these two squared deviations, 9 and 1, and the result is 10. Before we can calculate the sample sum of squares, we need to calculate the sample mean. The scores of 2 and 4 have a mean of 3. Let's calculate the sample sum of squares for these two scores. First, let's find the squared deviation of the first score of 2. As we can see, we take the score of 2, subtract the sample mean and square the result. Next, we find the squared deviation of the second score of 4. As we can see, we take the score of 4, subtract the sample mean and square the result. Let's simplify the total sample sum of squares. The squared deviation of the first score is 2 minus 3 squared, which is 1. The squared deviation of the second score is 4 minus 3 squared, which is 1. The sum of these squared deviations is 2. The sum of square total, 2, is less than the population sum of squares, 10. Here are all the calculations for the next pair of scores, 2 and 6. As we can see, the population sum of squares of 10, in blue, is only a little bit higher than the sum of squares of 8, in red. Here are all the calculations for the next pair of scores, 2 and 8. In this case, the population sum of squares of 18, in blue, is the same as the sample sum of squares of 18, in red. Let's finish the calculations for the rest of the pairs. As we can see, the population sum of squares, in blue, is greater than or equal to the sample sum of squares, in red, for all of these pairs. The total sum of squares for all the scores in the population is 10 plus 10 plus 18 plus 2 plus 10 plus 10 is equal to 60. The total sum of squares for all the scores in the sample is 2 plus 8 plus 18 plus 2 plus 8 plus 2 is equal to 40. The population sum of squares of 60 is greater than the sample sum of squares of 40, so the sample sum of squares underestimates the population sum of squares. For more help with statistics, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. You can also learn how to conduct more than 60 statistical analyses by watching videos that show complete solutions, or by working through an unlimited number of examples using the step-by-step problem solvers. Finally, you can access a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share with your friends, teachers, and professors.